In this video, I'm going to walk you through lesson 1 of the OpenSide Unit 7.1, which is all about chemical reactions. Now, this is a slideshow you can access in the window below. Go ahead and open the link and follow along as I walk you through lesson 1. Before we begin, though, there's a couple beginning slides that I'm going to share with you. And the first one is slide 2. Now, this is just a quick overview of the unit, and you will see that the unit is divided into 2 lesson sets. The first lesson set answers the driving question, what is in the bath bomb that causes a gas to form? During lessons 1 through 5, we do a lot of investigations about the ingredients that are in the bath bomb, what happens when you mix them with water, where are the bubbles coming from? Are they in the bath bomb, or are they something that new that's made? And we figure out those science ideas. There is a written argument, a summative assessment that can be found in lesson 5. And then lesson 6 has what we call a transfer task. This is the mid-unit transfer task where students will apply the science ideas that have been figured out to a new scenario. And so this one's going to be elephant toothpaste. Now, the second lesson set is about how can a new substance be made that wasn't there before. Now, this second lesson set is all about chemical reactions and how those chemical reactions make molecules break apart and then they rearrange to form new molecules, and those are the products of the chemical reaction. So we're going to develop those science ideas in lesson set 2. There is a written argument again in lesson 10, and then an end of unit transfer task about the Taj Mahal in lesson 14. So those are your real big summative assessment opportunities. There will be formative assessment opportunities throughout. And you can always create some small formative opportunities as well. A lot of teachers I work with create checks for understanding, small things that they can use for a grade to put in the grade book. So short little checks for understanding work great. Now over on the left, you'll see some driving question board categories. The reason I provide these is because teachers often get very nervous that the questions that students are asking are not going to relate to the unit. And if they do, you can have a category called Other, and that is not a big deal at all. But I will say that this first portion of the unit, the lesson set 1, is going to be all about the ingredients, the phases of solids, liquids, and gases. Matter might be a category you can use, bubbles, and density. Now, density is actually going to be developed in both, so it doesn't matter. You're not going to say, this is lesson set 1's categories. You're going to pretend that you are just collecting the questions and you're going to suggest category names. Now, this isn't always how people create a driving question board, but what I have found is that driving question boards are hard for teachers to do when they first begin. So there's many strategies. Try and find what works for you, but this is the strategy I use with teachers. When a student asks a question, the first question, let's say it's about what's in the bath bomb. So that would be about ingredients, but they're asking what's in a bath bomb. And then I say, does anybody else have a question similar to this topic? And then I go around the room and I collect all the sticky notes that are about that. And I place them all on the driving question board in one location and I categorize it ingredients. So I'm controlling the categories. Students are giving me questions that they think are in that category. Whether they are or they're not, doesn't matter, but you know you're getting that category on the driving question board, and they know their question is going to fit in there some way. So then I will go around. Anyone else have anything about, ingredients? No? Great. Who would like to offer the next question? So the next question might be about the bubbles. Anyone else have a question about bubbles? And I collect all the sticky notes about bubbles and I go and I post them all on the driving question board and I label it bubbles. So I am controlling the categories and I'm also controlling putting the sticky notes on the board because I have found that students are not great at managing all the chaos in the room. So I control it a little bit more. Now, if your students get really good at this or you have a really well-behaved class, by all means, let them come to the board and put it in the category. But the way this is done that I'm explaining, it really helps you kind of control the chaos of a driving question board. Now, in the second lesson set, we're going to get more into chemical changes. So some categories that might appear on the driving question board that would relate to this lesson set would be about scent, changes in properties or changes to the bath bomb or changes in general. Density is going to come back and molecules. So again, you're not pointing to where this is going to be in the unit because the students don't know this yet. All they know is at the end, their questions were figured out along the way through investigations. So let's dig into lesson set 1. We're going to start with lesson 1, which is the anchoring phenomenon routine. And you will see that this looks very similar to the storyline that was created by OpenSciEd. We still have the number of days that will take, but often, to be quite honest, it takes longer than the suggested number of days. You will see that we have the lesson question we're trying to answer. And then you'll notice instead of the picture of the investigation that's happening, I've provided links to resources, key slides, and I'm going to click on these as we go through so you get an understanding of what resources will be created or used in this lesson. Now, there is a link to this slideshow down below. So if you haven't opened it yet, go ahead and open it and follow along. All right, let's jump in. So first of all, we begin the class by observing a store-bought bath bomb and add it to water. And you will see the slide looks like this, and it's going to set students up to create a notice and wonder chart in their notebooks. And so you're going to first look at the bath bomb and you're going to make observations and you're going to put it in water. They're just going to write down things they notice in this column right here and what they wonder in that column right there. And then we are going to share out with the class what we noticed, and we're going to create a public record of this. These are our shared charts. So the class chart looks something like this. These are some things that people noticed when we were observing them in a training. And it says, bubbles floating on top of water. This is really easy stuff. You're just recording what they say, but I will tell you, try your best to use student language so you're valuing their ideas. Okay, now we're going to observe some homemade bath bombs. So in the teacher guide, I think it says, well, I didn't have enough money to buy different bath bombs, but I found some recipes. And so here's some recipes that we're going to look at. We've got several different bath bombs, and they're made with little ice trays. I'll talk about them in the prep section. But you are going to have students look at a number of different bath bombs. Some teachers actually have different groups observe different bath bombs and then they share out their observations to kind of conserve your number of bath bombs that you have. I think in the teacher guide, it says that each group will do 3, but obviously that's a lot of materials. So we observe some homemade bath bombs. And you will see that this is the slide that goes with it. It's prompting them to discuss with their lab group what they observe and what do they want to collect about the bath bomb. And you can give them different tools to make observations. I think it's suggested you give them some plates and toothpicks, a pipette or an eyedropper. You can give them a thermometer, but it's going to lead them in the direction of collecting temperature, which we're not going to be doing too much in this unit. So might avoid wanting to go in that direction because we're not going there. Anyway, so you're going to give them all this stuff and they're going to talk about what they're going to look for. And then they're going to observe their homemade bath bombs. And then we have students develop an initial model first individually. This is a really important scaffold before you have students share ideas out with the class, that they have something written down and have some independent thinking time. There are some thinkers that need a little bit more time to process information. So if you have people raising their hands and shouting out right away, those the ones that need a little more time to process really don't get their ideas out there. So this helps support them. So you're going to have them draw what they saw happen right before adding the bath bomb to the water, a couple seconds after adding the bath bomb to water, and a few minutes later. So we're scaffolding their observations by time. And so they're looking at it before, right when they add it, and a few minutes later. And then we're going to get together and we're going to co-develop a similar model with the class, although this one's a little different. We're going to mark A somewhere in our model. You're going to draw this as students share ideas. You're going to draw what they say. And then you're going to model where is A where is B, where is C, and where is D happening in the model. So A is a spot in the bath bomb before adding it to the water, and then a spot in the water right before adding it to it. So we're going to just mark like inside the bath bomb an A, and I'll show you what this looks like. Here's a sample that we made together in a training. Actually, this one comes from the teacher guide. So you can see that like we're just trying to point out A, B, C, and D, where these are happening. And this is important because it's going to come up in a moment. So then we're going to come together and develop an initial explanation and an initial model with what we think is happening at the micro scale. So remember we labeled A, B, C, and D. That's going to be your places of the micro scale. So here's the handout that you use with students. And so you will see this is a tiny sample of the bath bomb. That's before it goes in the water. So you're connecting the A, the B, the C, and the D to what students put on that consensus model. And you will see that there's also a part 2 where they're going to explain what they think is happening, what happened to the solid, and what caused the bubbles to appear. So a little written explanation. This is what we consider an initial written explanation. And then we're going to get together and we're going to compare our initial models. Here's a slide with some small group discussion protocol. I will say that discussions can be very hard for students, and this is the first unit of 7th grade if you're doing them in order. So you're going to need to really scaffold this process as well and give them some directions. And so you're going to give each group member an opportunity to share their model and explain them with their group. I suggest using a timer. Give each group member a minute and put your timer on the board so everyone knows they have the same amount of time. When it's your turn, turn your science notebook around so that your model faces the others in the group, so they're using it as a reference. And as your group notices things about each diagram, they're going to record the following in pencil lightly on their model. So a check mark by parts that are similar to what the other people drew in their model, and a question mark by parts of your model or explanations that are different or where your group is less certain. This is important because this whole lesson 1, we're trying to elicit questions. We already have some notice and wonders, and here's another place where we're not quite sure. So then we're going to, because it's a lesson 1, we are going to create classroom norms. This is the handout that is provided for teachers to use with the Open SciEd norms, but I will say it is much more effective to have students brainstorm their own norms. So you just give them this portion right here and have them come up with what that means in your classroom. I think we call these now classroom agreements now. Norms is kind of a rough word to use. All right, so then we create a class consensus model, and this is going to bring everybody's ideas from their group explanations and their group models and the models that they shared with each other. I guess they're individual models that they shared with each other. Now we're going to share out. Now, this is very helpful if you are not having students participate right away. Put them in a scientist circle, go around the room, have everybody add one thing to the poster. Or if you have a very large class, ask partnerships to decide on one thing they're going to add to the poster. And try not to repeat what other people said so we get a lot of ideas on the poster. So if a student starts talking about, you might even prompt, give me something that happened before the bath bomb was added to water. How did you draw this? Okay, you drew particles and then you would draw little dots or particles. All right, that's a sample of the bath bomb. Does anyone have anything to add to this? Okay, let's go to the next part. What happened at part B? A tiny sample of the water. So you're just drawing what they tell you to draw. You're not drawing what you know. You're trying to represent student ideas in the consensus model. Now, if people are unsure about things, you add a question mark. So someone said they're reacting, the bath bomb is reacting with the water. Go ahead and write it, but say, does everybody think that there's something reacting? Is anybody unsure about what that means? Okay, so then you're going to capture that question mark. So the question marks are what you're going for. Notice how many question marks there are. That means we've got a lot to figure out. Okay, so then we brainstorm a list of related phenomena. And so you will see this is a sample poster. I think this one comes from the teacher guide. And so these are all things in students' lives that they can connect to the bath bombs. So this broadens the idea of the phenomenon. It's not just bath bombs, it's Coke and Mentos, it's bubbles in a can of soda, it's boiling Orbeez. So all of these different things students have experimented with or seen or experienced. And so they can connect this to the unit. That means we're not just explaining one thing. And if we do, we can probably explain a lot of these too. So then we're going to create a list of questions and we're going to create a driving question board. Now, I will tell you, here's a sample that comes, I think, from the teacher guide. That is great. Students can see their questions. You can see they've got the categories there, and it's a pretty big class. I will say that this can be a lot if you have a large class. So often what I do is put students into groups and I have them share their questions with one another. And then I have them share out 2 or 3 questions that they all agree should be on the driving question board. So then I'm limiting the number of questions on here. So each group shares 3 things. There's also something called the question formulation technique, the QFT, which maybe I'll make something down the road on that, but that's another way you can make the driving question board. Here's an example that I made with teachers in a training, and they're in student hat. So they're acting as if, and they're thinking as if they are 7th graders. And you can see these are the categories they came up with. Now, I will say when I first started doing these types of events where I was training teachers on OpenSciEd units and facilitating the student experience, I was so worried that these categories were not going to come out. And every single time the categories appear as they should. Now, sometimes a category is left off. So let's say nobody asked anything about smell. That's perfectly fine. You can add it at any time later in the unit. Or you can come back and do some more observations right before you do that unit and bring smell to the forefront. We haven't really asked questions about this. Can we add this to the driving question board? Or when you hear the question somewhere in the unit, you say, hey, can we capture that? Why don't you go add that to the driving question board? So now you've been waiting for that question to be asked because this is going to be lesson, I think it's 12 or 13. Okay. So now we have developed the driving question board. We only have one thing left to do in our anchoring phenomenon routine, and that is to brainstorm some investigation ideas. And so this can be a little difficult for students at first. Sometimes you can take those categories and have each group make a question or an investigation idea about that category. But there is definitely ideas that will come out and they'll get better at this. And you will be surprised how many times students will suggest something that actually happens in the class. Actually, here's one right here. Try each ingredient in water separately and compare it to the bath bomb in the water. We do this. And so they will see that their ideas are in the unit. Okay, the last thing for lesson 1 is an exit ticket about classroom norms. Remember, norms or agreements are not a one and done. You're going to come back to them and revisit them, especially when you're having management issues. You point to your agreements and say, what did we do well? Where are we struggling? Okay, let's try and do better next time. So that is lesson 1. It is suggested 4 days. I will say take as much time as you need to do lesson 1 because it anchors the whole unit. And so you really want students to be invested in asking their questions and making observations. So if you're going to spend a lot of time anywhere, make sure it's lesson 1.